Fam, did you want to say something?
Yeah, I just wanted to, you guys ever proof of learning? Like, if you have just saw a few papers relating to that. Basically trying to prove someone's like basically learned, I guess, train a model on a data set. So you guys seem to be focusing on just like storing uh weights or intermodal weights that are basically agnostic to that, which I think is like,
Yeah.
obviously it's a lot lighter, but I was wondering if you looked into like some of the more
Yeah, yeah.
like heavier, yeah, tasks.
Yeah, we're familiar with the proof of learning paper, which it's not based on the weights, it's based on the gradient, a sequence of gradients
Yeah.
over those weights, which you can prove that the best way to the most energy efficient way to produce those sets of gradients would be to actually perform the computation that's required to train the model. So it's like a proof of work, it's more difficult to fake the gradients than just produce them naturally, and that creates a sort of POW of sorts for the training of the model, which is really great for machine learning systems that are doing something that's akin to a federated learning system, where the model is predefined. Okay, this is the model we're going to train. We're training a transformer model. But I think the large limitation for that is that it's no longer a collaborative system, because people come to it with their model and ask the other people to train it. There's no innovation on the part of the miners to say perform machine learning with a different type of algorithm to produce a different result. It's all just the algorithm is known beforehand, the weights are known beforehand, and the thing that comes to the system is the computation. So it's really like a net for computational power. It incentivizes the production, like the growth of computational power in the system. So it's measuring that alone, which is valuable, but I think there's a lot of limitations to that. One of them being that if what our proof of intelligence is actually measuring the information specifically. So the innovation in the system is around that thing that we're measuring, right? What you measure is what you master. And so we're not just a purely computational incentive mechanism. I think that's one of the things. And then another aspect is that when you have a federated learning system like the one that POI works around, the model's fixed, and I think that's limiting. The algorithm is often fixed. In this case, the POI. The substrate for the model is fixed, so you can't, for instance, innovate on different types of chips often. And then also it's the gradients that get passed around, which is actually highly expensive. So I'm not sure how you could take a POI system and put it on a blockchain yet, because if you had, say, a trillion parameter neural network, you'd have to validate the gradients on a trillion parameter neural network, which would be trillion parameter transactions to do the validation. At least that's how I imagine you would build it. I'm not sure how you would do it otherwise. And that's very limiting. Your system is likely to bloat substantially. So that was our take when we saw that paper.
Yeah, yeah. So yeah, I guess like basically you're trying to like obfuscate that and essentially just focus on the contribution. So like the information game between like these participating agents, you can call them, and like I guess you associate, I forgot the exact equation, but you associate the staking of each agent as well as like their voted weights across agents as well. But then you also include some bonding score as well for the verification, which I think was pretty cool. Still gotta obviously know more about it. Um, but yeah, I guess it kind of goes back to our conversation before. Like I'm wondering if you just like if it's possible to just have the bonding mechanism without the stake, without the individual nodes staking.
Yeah.
So like for instance, yeah, like I'm not sure if like I'm sure there's some like drawback to that that I'm not thinking of, but yeah, just kind of throwing it out there.
Um, it's a really good question. Ala, before I answer it though, Ala, how are you doing?
Doing well. I think I got my stuff set
Okay.
up. That should be good.
Like
Okay, great. Great. Well, I'll answer this because
Go
it's
for it.
actually a
Yeah.
really good
All yours.
question. But it's like, so in a decentralized system, you have to have some thing to tether individuals to, because everything's finite, right? So like IPs are finite. Everybody can just create a million accounts. right? So what's the finite thing that you can do consensus around, right? Because consensus is by its definition voting, right? It's reaching consensus amongst a finite set of things. But if you can't reach consensus around things that are infinite, because people will just be able to manipulate the consensus by creating an infinite number of the things that you would vote with. So it doesn't produce a market because that market could be easily fucked with. In Bitcoin, the thing that is finite is the proof of work, right? So we know that it's really the computation behind the proof of work, right? So that's finite, and that's so you can do a voting system on top of that. The proof of stake is just, in our case, is abstracting the finite thing as computation into the stake, where the stake represents work done through the mechanism over time, right? So people that have a stake have performed computational work inside BitTensor to produce it, right? So we need that thing that is finite in order to do the consensus to determine what the thing is in a trustless, decentralized way. So that's why the stake is used as that finite tether. If you could come up with another thing that is finite and tetherable, then you could use that. Like perhaps, people work on this concept of like proof of identity, like your proof of humanhood. You could maybe build something around that, but it's very difficult to bridge that gap between, meat space and the digital space in an effective way. We had originally tried to build the registration process as like an email verification. Like you get an email and you click and you solve a CAPTCHA. But the problem with that is that people would just go out and solve CAPTCHAs, right? And you just have people doing that all the time instead of it actually reflecting this, computational power that we're trying to incentivize in the network. So if you could figure out a way of making, one vote per person or something, or some equivalent, or one vote per organization, or however you want to build it, then you could perhaps do away with the concept of stake, economic stake. Hopefully that answers your question, fam. That's really interesting.
Yeah,
question.
no, I'm constantly thinking about it, and I haven't found. Yeah, it's just I'm hitting a wall, so I'm wondering. Yeah, I was wondering if you guys had any like thoughts on that.
Well,
yeah,
we also, here's another thing you might ask is, okay, well, great, so it's economic weight, but could we say apply a function to that economic weight? Say take the logarithm of economic weight, so that you're sort of pulling down the people that have more stake and pulling up the people that don't have so much, so you could level out the playing field, so it's not so Pareto distributed, which it is, right? The only issue is that without having a concept of how many accounts somebody has, if you're taking the logarithm of people's stake, everyone would just make 1,000 accounts, because when you take the logarithm over 1,000 accounts, it's going to be greater than the sum of one account with 1,000 tokens. So things like that actually arise as serious problems when trying to solve, perhaps you could say, like social problems in the space of anonymity or decentralized permissionless systems where there's infinite number of accounts and infinite number of identities. It's like very difficult. But I digress. I think, but it's a really great conversation to have. But let's digress because
let's not keep it up. Yeah. Thanks for
no problem. Floor is yours, Chib.
Okay, and I'm back. Cool. Can everybody hear me well? I hope.
Yep.
Cool. So thanks for the conversation, fam. I love that name. And Cons, thanks for. I know that you're traveling, so thanks for attending. So today's TGIF-T, Voon and I are actually looking forward to displaying two new things that we've been working on. The first being Voon's Unstake All feature. That's a PR coming in probably sometime next week. I know it's been highly requested. The second bit is the model guide. So the model guide is something that was suggested to me by a few folks this week, and then with some special help from Mr. Seeker, pointing me to a few code bases for us to play with. What it is effectively a way for you to train your model locally without connecting to BitTensor. So what that means is you can actually download and fine-tune a GPT-2 from Hugging Face without you needing to connect and to register and do the whole shebang of joining BitTensor, just so that you can at least tell with a litmus test of how it's performing. This way you won't end up with like a highly lossy model on the network doing nothing and then getting deregistered eventually because it's just not contributing. So without further ado, I could probably get started, and then Voon, you can probably jump in with your demo. Does that sound good? Okay. So this is not yet. So this is not yet available to everyone in the community because we haven't actually finished it yet. It's actually still a work in progress. We're hoping to wrap it up sometime, ideally next week, so that we can kind of release it at the same time as Voon's release, because it'd be useful. So this is kind of where it's at. We put together a MIDI guide for everybody to be able to run it themselves and be able to kind of run their own model. You can basically pick the name of the model. You can pick what data set you want to use. You can use, for example, Hugging Face's wiki text, or you can also use your own CSV files or whatnot, or you can also even use BitTensor's data set. So, for example, in BitTensor's, which is the mountain data set, just specify BitTensor and then you're done. And you can pick up your batch size, which we'll be explaining as well as for the guide, and your evaluation batch size as well. And you can tell that you want to do training and to do some evaluation on it when it's done training, so you can actually get a bit of an idea of how it's performing when you're testing it. And then some output directory. So what this does is this output directory is going to be containing the file, basically the torch file. So what's going to happen is when it's done, it's going to output to this directory that you want, whichever directory that you want, and it's going to be up to you to move it to the BitTensor mining folder that you have, which is basically the folder that contains your miner and your model.torch file. Replace that with this file that you've created, and then when you work in miner, you're going to be running the model that you've created here instead of downloading just something that's untrained from Hugging Face and expecting it to do well. So this will give everybody a really good fair shot at training your own model. But at the same time, I really highly recommend that you read up a little bit more on machine learning to understand what the different parameters mean and what they do, just so that you can get a better idea of what it is that you're doing when you're training this thing. So what this script does is it takes care of everything, really. You input what you want, and the output is a ready-to-use model on BitTensor. Now, one caveat is that highly good. I'm not speaking English properly today. Good performance on this script. If you end up with a model with a very low loss, so the loss that for lack of a better term, loss is what we measure to say how many mistakes a model is making. So the closer your number is to zero, the better your model is going to be. And the further away from zero it is, the worse your model is. Now, let's say you create a model that's really amazing and is very close to zero in terms of loss. It's not a guarantee that it's going to do very well on BitTensor, specifically because you don't know what other models are running on BitTensor. So it also requires a little bit of research as well before you actually run the script and to know what best model to train in the first place. The other tidbit is that this script really runs only with causal language models. So for example, things like BERT, DistilBERT, and so on, they're not quite supported yet just because the script really only runs on things like GPT-2, which I think a lot of people are running anyways. So without further ado, let's jump into a quick little demo to show you what it looks like and how it runs. If there's any questions, please feel free to ask in the general channel or unmute yourself and ask me right away. I'm more than happy to answer as I go along. Give me a moment here.
Hey, Al, I had a question.
Yes.
So you just said that what you're going to demo today doesn't show you how to actually determine what the validators will like compared to other models because you don't have that viewpoint. You just know that it's performing better on the BitTensor data set, which is
Exactly.
a pretty good proxy. It's a pretty good proxy for telling us whether or not it's going to perform well on the network. But it's not the be all end all. It's not the ultimate proxy.
Exactly
and I
right.
think
Yes.
so. I mean, that question I think needs to be answered at a later date, probably another demo, because the way to do that is actually to train a validator on
Yep.
BitTensor. And so in a way, and we will actually be demoing that and potentially showing people, we will provide some knowledge for the community on how to know that, and perhaps these are the parts of the data set you need to perform well on to do well in the future. I just wanted to add that comment on there.
Yeah, no, that's a very good point, Const. The other thing that I wanted to add on top of what you're adding is that this is also the first in a series of a lot of guides. This was actually a long time coming in terms of how do you even train something to go on BitTensor, right? So it's going to be useful to the AI engineers, it's going to be useful to you guys, it's going to be useful to really anybody who's trying to train something on BitTensor. Not everyone, like down the line as a network grows, not everyone's going to start deploying just random Hugging Face models. People are going to start wanting to customize. People are going to start wanting to create their own. And in this way, we kind of are leveling the playing field in a sense. But yeah, that's a great point, Const. Cool. So without further ado, let's get started. So this is almost an identical call to the one in the guide. It's just literally running CLM, which is the script that we created. You pick, let's say I want to train a GPT-2. I want to, our dataset name is BitTensor, which is the mountain. And then this is the batch size for training and for evaluation. And then I want to say I want to output this directory. So if I run it right now, it's actually going to complain and might not let me run it through. Because this test CLM is actually already there. So basically what this mechanism does, I want to be fancy and say that this mechanism is part of our way to prevent you from deleting your own miner on accident, but really this is just actually a bug. So this is running it again after we delete the mechanism, so we're good to go. So now you can see all the log outputs here. It's a little bit wordy, need to fix it up, but basically this says, this picks the CPU because there's only a CPU on my computer, there's no GPUs here. And this is Basically, this is the parameters of the model itself. You can, if you actually had dug into the tensor code, you can see a lot of these parameters are actually also existing in BitTensor as well. And then what it's going to do is it's going to download the model from Hugging Face and then start training, fine tuning it on top of my system. So the difference between fine tuning and training, that's something that everybody needs to understand, is training is basically training a model from scratch. It doesn't know anything. Fine tuning is the model's already trained generically, and then you kind of giving it more information. It's learning on top of what's already known. So, for example, in GPT-2, it's already trained and everything on Hugging Face. What we're doing is we're fine tuning it with the BitTensor dataset, so it becomes more compliant with the BitTensor dataset. So here you can use a weights and biases account if you want. It's just exactly like a miner, but what this does is this just puts it up on your own weights and biases account, and there's no actual mining happening. So here we don't want to actually visualize anything because we just want it to run and see how it's doing. This gives you here, actually the log statements is a little bit of work, but this gives you how many examples that you have, which is very, very small here. It's actually not nearly enough, maybe thousands, not 4, but this is for the sake of the demo. Number of epochs is how many times it's going to run, and then just some more settings of the model itself. And so what it's going to do is it's going to train for 3 epochs. So it's going to take a good, maybe solid 5 minutes, give or take, and then it's going to give me back how well my model has performed so far up until this point. Any questions, any comments while this is working? Because it's going to take a little bit of time. I'm also looking at the general channel if anybody has any questions here. But yeah, feel free, ask away.
How long would you expect this training process to be, Alan?
It's a good question. Depends on your system. So this is going to take probably a good maybe 5-10 minutes because this is like maybe 3 epochs barely. But if you're seriously training something and you want it to be fine-tuned and you're running GPUs, you're looking at a few hours probably, give or take. And then you can even extend that to days if you really wanted something fancy. It just really depends on your settings.
Have you completed a full epoch of our data set? That's probably going to take a good week, no?
Yes, I have not. I haven't fully done a full epoch of our data set. I've only done some very, really small training. So here, like the block size is tiny. I think it's 1. So we're only predicting the one next word, which is just garbage. This is really not even a usable model. This is just something that we're training just for the sake of the demo. But
what parameters would you use if you were doing this in practice and wanted to train a
you would want model? So a lot of the parameters, interestingly, are already on Subtensor, right? So you can pull that information directly. So for example, things like the block size, which is the sentence length, that's the sequence length, sorry, that's already in Subtensor, and we can pull that directly. So one of the things that I'm adding in here is a direct integration to Subtensor so that it pulls the parameters that the validators are using effectively. So this way you can be a little bit more compliant with the validators too at the same time.
Great. So it actually pulls the parameters that you need.
Yeah.
Okay.
Exactly.
But in this case, you set them directly, so that's why they're.
In this case, yeah. In this case, this is just whatever. This is again a work in progress. It's not quite done. It's actually a little bit of an early demo as opposed to a much more mature demo that we've shown in the past. But the nice thing is this is an end-to-end and it's working. So really at this point, it's just adding more stuff on top. We're not really doing anything new after this.
Okay, very cool.
There we go. It's done. So it gives you a little bit of the train metrics that you have and the evaluation metrics. So train metrics, my train loss is 6.3, which is pretty bad. But this is how it is. Train time took about 3 minutes. This is how many samples we used during training, which is very, very, very small. And basically just a little bit more metrics about my speed and stuff, which we want to fix. We want to have better metrics in this because these are a little bit useless. At the same time, this is the evaluation. So the difference between training and evaluation is what happens is when we get the data set from BitTensor, from wherever, we split it. We end up with a training set and a test set or evaluation set. And so, for example, if you have 100 lines of data, then you can split it between 80-20. So 80 of it would be training, and then 20 of it would be testing. So this is the remaining data set that is used for testing. The evaluation loss is still fairly high. Training accuracy is pretty bad. It's about 10%. And yeah, that's kind of effectively it. So that's kind of it for the demo from my side. This is still a work in progress, but this is going to be one of many incoming model tools that you're going to be able to use to kind of train your own model, or to be used as an example for folks who already know how to build models using AI and to kind of integrate into the BitTensor ecosystem.
Can you show us where the model is that was trained and perhaps how you would set it up to run in a BitTensor miner?
Yeah, 100%. That's actually a really good point. So let's see, where did this model go? I can't remember what the path was that we did here. Okay, actually no. So if we go into /tmp, and then we go into test CLM. So this is where the model would be. So you have basically a bunch of stuff in here. So things like all your results that you have so far. So if you look at all results, this gives you really all the results that you got so far in your evaluation and your training. Your model is here. So this extension is a .bin. It's actually supposed to be a .torch. That's a mistake, but it doesn't. It's not really a huge difference. So all you need to do is just take this .bin file and then put it inside where your miner would be. So let's say, for example, I go into Tensor and I want to go into, where are my miners? I actually can't remember where the miners would be in Tensor. Miners. Yep. So let's say I have my M1 miner and M1 advanced server, and this is the model of the torch. So the file that I've created inside of temp test CLM PyTorch model here, it would need to be placed in here. So here, and then I could say .torch. So all I do is just I replace my model.torch with the PyTorch model bin that I have, and I'm good to go. This is again going to be part of the and so you see we kind of most recently updated it today, June 23rd, and it's good to go. I just trained the model, I just put it inside my advanced server, and all I have to do is just run my advanced server like I normally would, and I'm good to go from there.
Yay!
And
Woo!
we're going to include like a template server that only does an inference, but does the same, like allows you to import the file as well, right?
Yep, absolutely. We're gonna do the whole shebang, but for now, this is kind of just a skeleton, bare bones end.
You can use this model right in the advanced server, and I believe you
Yep.
can just turn off training Voon, which would be the equivalent to what you're suggesting.
Oh, with the flag. Okay.
Yeah, you just I can't quite remember what it is, but it's probably like --neuron dot model train no, or no model train. If Eugene's on the call, he probably actually knows.
I think he's in a meeting.
Yeah, okay, it's okay. But it exists, so you could there he is.
I'm here, but I need to look it up too because I haven't.
Okay. Well, that can perhaps be added to the document demo once this is ready to go.
So yeah, so that is it for the demo on my end. If there's any questions or anything?
Thank you, Al. That was really nice.
On the flag is literally just neuron.training, so you'd make it false.
Yeah.
There you go.
Have we done this yet? Has anybody
Have we
done it
done?
yet? I think Caro was doing this at one point, but not with your code.
Yeah, I was doing it as well, and Mr. Seeker does it. He's mentioned he's done a couple days at least of fine tuning. He even downloaded the data set as much as he could,
right?
So you could have a faster training instead of pulling it.
So we're destroying Mr. Seeker's arbitrage opportunity.
Destroying the efficiency.
Yes.
We're gonna have
That's
to
exactly right. That's exactly what we're doing.
That's was this his idea?
It was his suggestion to use the script that I adapted. So yeah, okay. I'd say partly. And then the other bit is kind of everybody reaching out to me more recently saying, we need a way to test things without registering. And that's kind of where this popped out. So a lot of kudos goes to Mr. Seeker though, 100%.
Awesome.
There's no more questions. Voon, you want to take it away?
Yeah, Voon had something, right?
Voon, this is so great. Oh, there you are.
So I'm on the PR right now, and then we have a couple new flags you can use with the unstake and stake commands that let you unstake and stake from all of your hotkeys. You can also specify them. This is just a breakdown of it. So you can do wallet all hotkeys, and it'll unstake all of them. It'll still ask you for the amount, and it'll do that amount on every single one, or at least it'll try to do it on every single hotkey. You can also specify them using a list like that. So you do like hotkey 1, hotkey 2, hotkey 3. You can also exclude specific hotkeys. So you would say all hotkeys, and then you would also specify which ones to exclude from all. So say you didn't want to unstake from these 3 hotkeys, you would list them like that. There's also, in combination, you can use it too, a max stake feature. So it'll only work in one direction each time. So stake will only stake it on, whereas unstake will unstake from the keys. But you could use both commands to then reach an exact level for each. But you can specify what stake level you'd want to have on each key that you're doing a stake or unstake from, and it'll try to reach that for you. So there's only max stake because I figured that was the only one that made any sense. But you could say say you only want maximum 10 tau on every single hotkey that you're staking to. It'll find out how much tau it needs to stake on those hotkeys to reach 10, and it'll try to do a stake for each one. And then same thing for unstake. If you wanted a max of 10 on each, it'll unstake the excess. Anything under 10, it'll just not do anything to though. So we can see on my command line, I'm gonna demo it. So I'm doing an unstake, I'm specifying my wallet name, and I'm specifying some hotkeys. So it's this hotkey, and then this is just a bash way to say different hotkeys named P100 to P101, P102, etc. And I'm doing a max stake of 100. So to loop through after the network, it's going to loop through all of my hotkeys. It's going to check their state, and it's going to decide how much I need to take off each of them, each max stake of 100. So you can see it's going through all 12 of them. And then at the end, it'll give you a summary and asks to confirm first before you actually do it. And this only works for one cold key per command. So if you have multiple cold keys, you're going to have to specify them separately. Like you're gonna have to do the command again and again. But it's you can see because my other hotkeys don't have over 100 stake. This one has an extra 711 over. So it's going to ask me if I want to unstake from this hotkey, this amount of tau, and then I would press yes if I wanted it to. I'm not going to do that though. But it would have just continued and it would have just done it and finalized. And then you would have seen it being unstaked. And then it would be the opposite for the stake feature.
Wow, Boone, you're loaded.
Yeah, well,
I was just gonna say that.
711.
Damn.
700 town. I've never seen that much town in my life.
Does anyone have any questions about that?
Yeah, Boone, where do you live?
Where do I live? I live in the office currently, sleeping under the desk.
Fair enough.
Did you trade it? Did you trade in your motorcycle for a gold-plated one? Is this what happened?
No, I should though. Yeah, I should. I gotta trade it for a bus pass.
Oh god.
A gold-plated bus pass.
Cool.
In Toronto.
They have a couple Presto cards like that. Not gold plated, but they're
But
deco.
on point. This is really great. I think convenient for a lot of people that are running more than one miner, and that have multiple up there. So very cool. Thank you, Vin. So I think that's actually it. So I guess we just open up the floor at this point. If anybody has any questions about those two presentations for us, that's time. Saves me an hour and a half of unstaking. Yeah, totally.
Yeah.
It does
and I'm
have to
assuming-
submit every of them separately though. It can't do it all at once. So if you have a ton of keys, which unlikely you'll have enough to make it take a long time, at least you don't have to type it.
You don't have to unlock your key every
You
time.
only have
though.
to unlock it once. It'll unlock it at the
Okay.
start, and then it'll do it for every key. Again, it's only in one cold wallet. So if the hotkeys are under multiple, you're gonna have to do that command for each cold wallet they're under.
That makes sense. So then if I wanted to balance out all my keys, let's say I've got, let's say I've got one server or one validator with like 100 tau, and I've got like another 9 that have all 1, and I want to have all of them at 10. Can I just say max stake for all of them to 10? And it's going to basically take out from that 100 tau?
You have to do an unstake and then a stake.
Yeah, sorry. Yeah, unstake and then a stake, yeah.
Yeah, so what you could also just unstake from each of them without doing the max stake, or just unstake from like the larger one enough to
Yep.
fill the rest, and then max stake 10, and then it should do it to each of them up to 10. But if they have more than 10, it won't stake anything to it. So the one that has a lot, it won't change it in the stake command. It only lowers it with unstake. So that way it does exactly what the command says. If it's gonna unstake, it unstakes. Otherwise, if you do a stake, it'll stake, right? That way you don't get any confusion.
Yeah, that makes sense. That makes a lot of sense, actually. Cool. Nice job, Boone. That is useful as fuck.
I have a question. What other tooling do we need on the CLI that people are using? So this is kind of open question to the community.
People should file in some tickets on the GitHub itself, right? You can actually request things over there.
There's an issue. I think it's gone now. I think Timo put it up. Yeah, BTCLI list user quality improvement, and then we got to, it was January 18th, and we got to it 2 weeks ago, but we just said we're not doing it.
In your face, Timo.
It was just for list. He wanted to see if it was active while doing the list, but the thing is, we don't want list to have to query the network. We want it to just be in the file system, so it doesn't make sense to put that in list, and it already exists in overview.
So we got there.
Is there any questions in the general channel?
I'm checking in right now.
There's one
Yep,
feature I'm
seems good.
implementing right now, another one on the CLI. It's kind of minor, but when you type like the network name or the wallet name, if you do an explicit flag for it, if you use the default names for stuff, it'll still ask you to like retype it when you're using the CLI. So if you were to do like subtensor.network Nakamoto, it's going to ask you if you meant to say Nakamoto, which is kind of annoying. So I made it so it'll not do that anymore. So if you specify it in a flag, it shouldn't ask you again.
This is true. That's a good
I've
point.
got to ask you how you did that, Boone, because I implemented that
Oh
bug
yeah, it's
and
you can
I
yeah,
couldn't
the
figure out how to.
arg parser, you can do arg parser suppress and then it won't include it
So
in the namespace.
then you should implement some fuzzy logic so that if I misspelled Nakamoto, it should say, "Did you mean Nakamoto?"
No, yeah, it does that.
Uh,
Oh, like that. Yeah.
so when
It'll just tell you you're wrong.
if you type in, the wrong address, it just goes, "Hey, did you mean to send it to const?" And then it just doesn't let you get out of that.
But when you
loop.
do the transfer, I have it verify. Like I added a thing to verify it. So if you type in an incorrect address, it's gonna check first if it's a valid, like in the valid space of addresses. That way you don't like
That's
do one typo off or something, and then you send away all your tau.
that's great.
I think it would have errored regardless, but if you had like something that was like mostly valid, that'd be bad too.
Razlan says, "I'd love to see those training custom model commands you play around with, even if the guide isn't complete." Do you want to throw those in the chat here?
Which one's sorry? I missed that.
The
I think your entire presentation.
The GitHub guide.
yeah. Can
I
you
can
just
put it in,
host the?
but it's not quite ready. So use at your own risk.
It's not
That's
quite
my only caveat. Yeah,
I see. Okay.
that's
Yeah,
why I kept it
or just wait, Razlan.
because,
Yeah.
I wanted to get it to like work perfectly and then give it to everybody so that people can use it without issue. Because I feel like right now, if somebody tries to run it, they're like, "What is this? It's not working."
It looks
So
like
yeah.
Lucas boosted us twice.
Yeah, I saw
Thank
that.
you, Lucas.
We got the boost.
Got the boost. Somebody
Thank
was
you, Lucas.
mentioning, I think it was Caro was mentioning, and I don't know if anyone in the community would be interested, but like potentially some of us could do live coding or something on Twitch.
Oh God.
Yeah, that would
It's
be a
not
lot of fun.
mandatory or anything, but I'm sure Caro could do it at least.
I was thinking about doing it this weekend when I get back.
Yeah, it's something
It'll
that
be
I
a
want
lot-
to be
It'll be fun.
doing at some point.
Or go ahead.
I was just saying that, yeah, the live coding on Twitch is something that I want to get us doing at some point soon. So, yeah, that's definitely going to be happening.
We need to get George Hotz to do coding to like hack our system. You know what I mean?
I actually didn't get that.
We got any George Hotz fans in here? George Hotz,
I think
the guy who
from
jailbroke
the
first
silence
iPhone.
I think from the silence, Caro, most of us are not fans of this guy. Or even knew what you were talking about.
He's my hero.
Caro brings this guy up a lot.
Yeah. Geo Hot, Tom Cruise. He got sued by Sony and made like a diss track. It's pretty elite. And then he made a self-driving car startup, from an iPhone.
That
So
sounds
like
right.
so like he makes sure you just plug your phone in your car and it can drive.
Have you heard of what was his name? Something Wodowski or Lewandowski, the Google employee who was working on Waymo and then left and stole the code to Uber after getting $150 million severance pay, or no, $150 million. He got $150 million year bonus and was like, "Well, fuck you, I'm leaving to start my own company because $150 million is a lot." And he got in legal trouble with Google after giving the code to Uber. But he also went off to start a religion centered around artificial intelligence. I feel like he's someone we should get into this call.
Yes. What's his last name?
Let me find it right now. Google employee
Ludwig?
AI. Yeah, that sounds right.
There we go.
What's his name?
Anthony
yeah,
Lewandowski.
Anthony Lewandowski. That's the dude.
He seems like a pretty chill guy. Pretty chill dude.
Yeah, perhaps. I like his AI god. He founded a religion around AI, which I think
Oh my God! You have to read the
be
short
bullish.
story I posted in X Cross Topic a few weeks ago.
Is it about Anthony Lewandowski?
No, but it is highly related, and you should absolutely read it. It's only like 20 pages.
Okay, sure thing. But he did actually start a religion around
Yo,
AI, which is pretty
Lucas,
incredible.
thank you for boosting, bro.
We
Wait,
already
is he in
sound
this
like
call?
Twitch. Yeah, he
Yeah, I
is.
see him.
I was gonna say we already sound like we're Twitch streaming with that.
Hey, thanks for the 10 bits.
Donate to my channel. Thank you.
Yeah.
Someone
Great,
donates
Alex.
$3.
The model guide's up. That's fantastic. So it's but use at your own risk.
Yep.
Correct, Alex.
Yep.
Okay,
It's not quite
so-
there yet. Yes.
Is the AI God or is it the cars? Or is it the car AI?
All of them.
All of them. Are there lesser gods?
Lesser
Is
gods.
my-
very
is
serious.
my Kia AI worse than your Tesla?
My Beamer AI is much better than yours.
Yeah.
Or the JI is better?
My Beamer AI encourages me to change lanes without signaling.
That's
With
AI. Well,
Cool. I
before
think
this
that,
turns into a Twitch stream, why don't we let everyone go? I suppose there's no more
Yep.
presentations. Correct, Al? Yeah.
I think we're all
Okay.
good. Yeah, we're all good. Cool. Thanks everyone for attending. It was really good to see everyone's beautiful profile pictures. We'll see y'all later.
Bye,
Ciao.
guys.
See ya.
Ciao.